Ever wondered how a group decision can be more accurate than a single expert opinion in machine learning? Well, it's all about a concept known as ensemble learning, and it forms the foundation for something we call voting classifiers. This idea is pretty powerful. Think of it like this. If you're trying to predict the weather, would you rely on just one forecast? Or would you feel more confident if you checked multiple sources and took a majority vote? That's essentially what voting classifiers do. They combine the predictions from multiple machine learning models to make a final decision. And the beauty of it is, this approach can significantly boost the accuracy of our predictions. It's like tapping into the collective wisdom of a panel of experts instead of relying on just one. So, voting classifiers can be a powerful tool in a data scientist's arsenal, don't you think? Now let's dive deeper into how voting classifiers actually work. At the heart of voting classifiers, there are two distinct types: hard voting and soft voting. Both types operate on the same basic principle of utilizing multiple machine learning models or classifiers to make a final decision. But how they arrive at that decision is where they differ. Let's start with hard voting. Picture a roundtable discussion where each classifier gets one vote. They all make their cases, and the class that gets the most votes wins. This is the essence of hard voting. Every classifier in the ensemble has an equal say, and the majority rules. But what if some classifiers are more confident in their decisions than others? Shouldn't their votes count for more? This brings us to soft voting. Instead of simply counting votes, soft voting calculates the average probability for each class. Each classifier not only votes for a class, but also provides a probability estimate of that class being the correct one. These probabilities are then averaged, and the class with the highest average probability is chosen. This means that a highly confident vote carries more weight than a less confident one. Think of it like this. In a soft voting system, our classifiers are not just voting, they are also debating. They're not only saying, I think this is the right class, but also adding, and I'm this confident in my decision. This added layer of confidence often leads to better performance, as it allows the ensemble to capitalize on the strengths of its individual classifiers. In both hard and soft voting, the goal is to leverage the collective wisdom of multiple classifiers to make a more accurate prediction. Each classifier in the ensemble contributes its unique perspective, leading to a decision that's often better than any individual classifier could make on its own. In essence, voting classifiers are all about teamwork, with each classifier's decision contributing to the final decision. To wrap up, let's summarize the key points about voting classifiers. Voting classifiers are a fundamental concept in the world of machine learning. They form the backbone of ensemble learning, a method that combines several models to produce an output that is more accurate and reliable than any single model could produce on its own. The power of voting classifiers lies in their ability to harness the strengths of multiple models, effectively pooling their knowledge to make more informed predictions. One crucial aspect of voting classifiers is the distinction between hard and soft voting. In hard voting, each classifier in the ensemble casts a vote for a class, and the class with the most votes is chosen as the final prediction. It's a simple majority rule system. On the other hand, soft voting takes into account the confidence of each classifier's prediction. Instead of simply counting votes, it calculates the average predicted probabilities for each class and selects the class with the highest average probability. This approach can often lead to more accurate predictions as it considers the degree of certainty behind each vote. But remember, voting classifiers are not a one-size-fits-all solution. They work best when the classifiers are as independent from one another as possible. That's why they are often used with different types of models, or with the same model trained on different subsets of the data. This diversity allows the ensemble to capture a wider range of patterns and relationships in the data, which can further improve the accuracy of predictions. So, it's clear that voting classifiers are an essential tool in machine learning. They provide a way to combine the strengths of multiple models, improving the robustness and accuracy of predictions. They offer flexibility with options for both hard and soft voting. And they encourage diversity among classifiers, which can lead to a more comprehensive understanding of the data at hand. So next time you need to make a decision in machine learning, remember, two heads are better than one, especially when it comes to voting classifiers.